Welcome to our problem-solving session. Today, we'll solve a physics problem involving the time it takes for a stone to fall down a well and for the sound of the splash to be heard. Let's first understand the problem. We're dropping a stone into a well, and we want to determine the depth of the well. We're given that it takes 4 seconds from the moment we drop the stone until we hear the splash. This total time consists of two parts: the time t_1 it takes for the stone to fall and hit the water, and the time t_2 it takes for the sound of the splash to travel back up to our ears. We know that the total time is 4 seconds, so we can write t_1 plus t_2 equals 4 seconds. Now, we need to understand the physics involved. The stone falls with acceleration due to gravity, and the sound travels at a constant speed. For the stone, we use the equation for free fall, d equals 1/2 gt_1 squared, where d is the depth of the well, g is the acceleration due to gravity, which is 32.2 feet per second squared, and t_1 is the time it takes for the stone to fall. We can simplify this to d equals 16.1 times t_1 squared. For the sound, we use the equation d equals v_s times t_2, where v_s is the speed of sound, which is 1,120 feet per second, and t_2 is the time it takes for the sound to travel up. Now, we have two expressions for the depth d. Since they both represent the same depth, we can set them equal to each other. We also know that t_1 plus t_2 equals 4 seconds, so we can rewrite t_2 as 4 minus t_1. Substituting this into our sound equation, we get d equals 1,120 times for minus t_1. Now we can set up an equation to solve for t_1. We have 16.1 times t_1 squared equals 1120 times for minus t_1. Expanding the right side, 16.1 times t_1 squared equals 4,480 minus 1120 times t_1. Rearranging to standard form, 16.1 times t_1 squared plus 1120 times t_1 minus 4,480 equals 0. This is a quadratic equation in t_1, which we can solve using the quadratic formula. Let's identify the coefficients in our quadratic equation. We have it equals 16.1, b equals 1120, and c equals negative 4480. Substituting these values into the quadratic formula, t_1 equals negative 1120 plus or minus the square root of 1120 squared minus 4 times 16.1 times negative 4480, all divided by 2 times 16.1. Simplifying what's inside the square root, 1,120 squared is 1,254,400, and 4 times 16.1 times negative 4480 is negative 288,512. 1,254,400 plus 288,512 equals 1,542,912. So we have t_1 equals negative 1120 plus or minus the square root of 1,542,912, all divided by 32.2. Computing the square root of 1,542,912, we get approximately 1,242.14. So t_1 equals negative 1120 plus 1,242.14, or negative 1120 minus 1,242.14, all divided by 32.2. The first gives us approximately 3.793 seconds, and the second gives us approximately negative 73.36 seconds. Since time must be positive in this context, t_1 equals 3.793 seconds is our answer. Now that we know t_1, we can find the depth of the well. Using d equals 16.1 times t_1 squared, we get d equals 16.1 times 3.793 squared. This gives us d equals 16.1 times 14.39, which equals 231.63 feet. So, the depth of the well is 231.63 feet. Let's summarize the solution. 1. We found that the stone takes 3.793 seconds to fall down the well. 2. The sound takes 4 minus 3.793, which is 0.207 seconds, to travel back up. 3. The depth of the well is 231.63 feet. This problem illustrates how we can use physics to determine distances indirectly. The sound travels much faster than the falling stone, which is why the sound travel time is so much shorter than the falling time. This is a classic physics problem that combines two different types of motion. 1. The accelerated motion of a falling object. 2. The constant speed motion of sound waves. By setting up the appropriate equations and solving them algebraically, we were able to determine the unknown depth of the well. Thanks for joining us for this problem-solving session.